Hi, I'm Pat Kelly. Okay, now this problem, the situation they describe is that we're going to toss 4 coins. That's our experiment. And the variable that they tell us is the number of heads. And they tell us that could either be a 0, 1, 2, 3, or 4. I'm going to list those numbers even on the board. We need them. But I'm going to start by telling you, when we toss the 4 coins, try to think of it as 4 different coins. Okay, so we're going to toss a penny and a nickel and a dime and a quarter. I say that, keep that in mind, and I say to keep that in mind because even the variable, those values that it can be, they told us it was 0, 1, 2, 3, 4. But I'd want that to make sense to you because if we toss 4 coins, maybe none of them are heads, or maybe only the pennies ahead, or maybe only the nickels ahead. And the way I just said that is both of those last 2 situations would count for 1 head, so we have to keep that in mind. And actually, all the stuff that I pre-drawn here is to keep our thoughts organized. And I'll tell you that I think that's going to be the key to this problem, is just keeping your thoughts organized. Okay, so here we go. They ask us to find the frequency distribution and the probability distribution for this situation. We're actually going to do that in that order as well, and I'll tell you why when we get done with the first one and head into the second one. Okay, so a frequency distribution, as we learned in this lesson, keeps track of 2 things. In the first column, we need to know the values of x. Those are the 0, 1, 2, 3, and 4 possibilities. The second thing we have to keep track of in a frequency distribution is the number of different ways each of those outcomes could occur. This is where we're going to have to try to get organized. Because if we talk about tossing those 4 coins, we're now going to try to start to count how many different ways could you get 0 heads. We'll see that that's just 1. How many different ways could you get 1 head? That's where I'd said if we think, well, the penny could be, the nickel could be, the dime could be. That's 4 ways. But instead of trying to rely on that type of thought process, let's use a little bit of a diagram. So in this diagram, I want you to imagine tossing first the penny, and then second the nickel, and then the dime, and then the quarter. So sequentially here, first we toss the penny, and that could either be a head or a tail. This diagram is going to help me organize my thoughts in terms of the different possibilities. So this top tree keeps track of the possibilities if the penny is ahead. And if the penny's ahead, then I toss the nickel, and that could be a head or a tail. Then I toss the dime, and that could be a head or a tail. And my diagram branches out now then, because if the penny were a head, the nickel were a tail, I still want to account for the dime being either a head or a tail. And then I toss the quarter, and in each of those possibilities up to this point, the quarter could be either a head or a tail. So we get the HTs all the way down. Okay, and I take a step back, and I have this whole second possibility of the first coin, that penny being a tail, and then again the nickel could be heads or tails, and the dime heads or tails in either situation, heads or tails for the quarter. Okay, just to take a breath there, that was the purpose behind this organizational scheme, is just to try to keep track of the different ways that this experiment can play itself out. One way that the experiment could end up is if I now read up and across these branches, I could get heads, 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 heads. All the coins are heads. Heads, heads, tails, sorry, heads, 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 but then tails. I'm trying to be very particular about making sure I grab the right letter here with each branch. H, H, T, H. finally, t, 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 t. Okay, so that was a bit tedious, but it keeps organized the different possibilities of this experiment. And the reason why I had said to keep the different coins in mind is because notice like this second entry has 3 H's and 1 T, but the next entry also has 3 H's and 1 T. Those are different possibilities. The first would be the quarter being tails, but the next would be the dime being tails. Okay? And that's going to help me now find my frequencies, the number of times that each of these different variables occurs. To help myself even more then, let me actually go back over here and let's just do the counts right now of how many heads. Remember our variable was how many heads did you get? So in this first it was 4, 3, 3, 2, 3, 2, 2, 1, 3, 2, 2, 1, 2, 1, 1, 0. Okay, because now our work will just be to count the number of different zeros. So if I look at all the blue numbers, there's only 1 0. Now I need to count all the different ones that there are. There are 1, 2, 3, 4. Frequency for that value of x is 4. Count the number of 2's. 1, 2, 3, 4, 5, 6. Count the number of 3's. 1, 2, 3, 4. Finally, count the number of 4's, which is just that once. So quick breath, because that's the answer to the first half of the problem. It took quite a bit of work. But our frequency distribution lists all the different values that x can be and the corresponding frequency to each. And now we move on to the probability distribution. And the reason why I said to do these in order is because for the probability distribution, we're going to keep track of x and then its corresponding probability. And to find the probability, you need the total number of possibilities, which I always come back over to my frequency distribution and grab the sum of this column, 1 plus 4 plus 6 plus 4 plus 1, that's 16. The significance of that is that there are 16 different ways for these experiments to play out. So each of these values of x will have a denominator of 16. Okay, so I grab that 16, just put it for the denominator of each of these. And for the numerator, you're now just grabbing the actual frequency that would correspond. So 0 had a frequency of 1. That's now my numerator. 4, 6, 4, and 1. So they asked me for the frequency distribution and the probability distribution. This probability distribution then lists all of the x's with the corresponding probabilities. And I have both of the things that they wanted me to do for this problem. A bit of work, but I think we have good answers. Okay? Thanks, and I hope that helped.